Hello and welcome to the Ink 3.0 workshop. Sorry that it took a little bit longer. In this workshop, we are your guides. So first of all, Andrew Jones, then me and Thibaut. Thibaut is your host in that sense that he will query the chat while Andrew and me are giving the presentation in the workshop. And if you have questions, he is going to interrupt us and ask your questions so that we can interactively, or as interactively as we can, give the answers right away. This is the format of the workshop. So please, if you have questions, write it to the chat. And if it wasn't clear, that's me. So there are no real prerequisites. Although knowledge about smart contracts and Rust is definitely helpful, and also, of course, knowledge about Substrate. However, if you were watching the Sub0 Inc. 3.0 presentation today, it might already suffice all your needs. And besides that, we are definitely trying to explain everything we do. And yeah, even if you do not understand some details, please just ask them and we'll explain them. So the roadmap for this workshop is, first of all, we get you set up with Ink 3.0, showing you how you can get set up. And then I'll present a little bit of an overview of Ink. I'll do this by writing some example contract and explain it in detail, unlike I did in the presentation today, where I just gave a really high-level overview of everything. Then followed by some demo how we can execute this using the CLI tool and also the Canvas UI tool by Andrew, as well as setting up your own Canvas node so that you can actually run it on your local network. Afterwards, I'll be giving a deep dive into the Ink storage. This is very important and has never been publicly available as material, and I think it should be available, and we'll definitely have some workshops about it in the future. But so far, this is the first time we'll actually explain this deeply. And in the end, finally, we'll explore a little bit about traits and tricks about Ink, and maybe you will have some questions and we'll get to answer more of them. Yeah. And let's dive in. So the setup instructions are all in this link. We just provided them through the list. Maybe I can just share them. And maybe I can just click on it and...
Don't bother, I'm going to do it.
Okay, then Thibaut is basically guiding you while we are going on with this presentation. It just demonstrates what you need to get your Canvas node, to get your Rust, to update to the nightly that we need, etc., etc. So the link is going to be included in the next slides, so don't worry. For the Rust setup, I chose Visual Studio Code. It's, in my opinion, the really good editor for code editing purposes, and for some kind of an IDE experience, I definitely can recommend the Rust Analyzer plugin for it. Unfortunately, we have to use a nightly compiler toolchain for the Rust because there are some tiny features, some tiny nightly features left in Ink that we are still using. And for everybody who's still new to Ink, I can also recommend Clippy as a further helper if you like. It is just a really good teacher. It's more or less a linting tool for Rust code, and it's among the best tool you can just install, especially if you're new to Rust. And everything that you do in Ink, you can, like, it's just Rust code. So all the Rust tools apply to Ink code as well. We are going a little bit deep into an ERC20 contract. This might sound a little bit boring. We haven't done it. We have done it a lot of times in the past. But I'm trying to do some new stuff in it that is some new features from Ink 3 and try to tell you a little bit about them while I'm programming it. And now let's dive into the live demo. For this purpose, I think I have to switch my window now. Maybe to that one. For this purpose, can you see my console?
Yes, absolutely.
Nice. For this purpose, I'm here in my console. Is I hope the console text is big enough for you? Can you confirm?
Definitely, yeah, it's readable.
Okay, so first of all, we check if our cargo contract version is correct. It should show 0.7. This is the Ink tool, build tool that is highly integrated with Ink nowadays. So you definitely need it. And for example, oops.
Just a heads up, Robin, when you're writing toward the end of the screen, we are actually not seeing it because it's, there is our faces on there. So if you can clear regularly the console maybe.
Okay, this is...
No. Yeah, exactly. Thanks.
Okay, so the next thing we do is we create a new contract using the new command and call it ERC20. And this created a new directory into our current working directory. It includes, let me show you a little bit more. It includes a cargo toml, a gitignore, and a libras file. And we can now open it in our preferred editor. You can see it. Is the size big enough again?
Yeah, I think it's good now.
So what causes a lot of confusion is that while we have specified that to create a new ERC20 contract, we did not end up in receiving actually one. Instead, we received something that we call flipper contract. So it just contains a Boolean, and this is by design because what we do not dispatch on any name or so. We simply construct always this flipper contract in order to give you something that compiles right away and does something. But for our purposes, we are going to delete all of this code because we are writing from scratch a new smart contract. So the only line I'm leaving is this import statement. It's not necessarily needed, but we do it for convenience so that we can just use ink as name. So first of all, we define our module in which all of our code is going to live. Modules in Rust are ways to structure your program. And we can annotate this module with so-called attribute macros. What I'm currently writing is an attribute macro. And this attribute macro tells the Rust compiler to invoke certain procedural macros. And one of those is ink. Ink is therefore just by design embedded into the Rust programming language. So everything inside this module is available to the ink compiler and therefore can be used as an ink statement. For every ink contract, we have to define some storage. And normally, we designed ink in a way that the entire, while the code lives inside this module, when we refer to our contract, we refer to this type. So this is basically the type represents our contract. This is very important. So we could even say that our module is called XXX or foo or whatever. The name match doesn't even matter. Like what matters is this name. This name, the big one, ERC20, is the important one. And a storage struct definition includes always the layout of our storage. And the storage is the database that contract privately owns, privately manipulates and organizes for itself. So for an ERC20 contract that has accounts and accounts with balances and that can transfer balances from account to account, we first of all have a total supply, which is of type balance. And also we have a balances field that is of type hashmap from account ID to balance. So what does it mean? If you know Solidity, this is more or less like a mapping from account ID to balance. And furthermore, inside an Inc module, this is special to Inc and it's not usual in Rust, you have access to balance, account ID, hash, block number, and all these primitive types. Outside of Inc, you would not have them. For example, if I do this, Rust analyzer should say that this is not available to me. I cannot find balance, but balance is very well in scope here. And the current message, like Inc is currently telling me that it misses some Inc messages. So as you can see, the IDE Rust analyzer and with its type hints inside my IDE actually includes all the Inc specific error messages. So this is an Inc specific error messages. It does not have anything in common with Rust error messages. So this is only like these errors are only available inside when you are programming with Inc. So let's satisfy our compiler and give him our messages. So I'll just quickly make a total supply getter. And now Inc should be fine with that. It still says something. Oh yeah, we need public visibility. So Inc has our backs if we do some typos. And now we are missing a constructor. So as you can see, Inc is designed in a way that it, if you know the absolute basics, it basically tells you what to do and what it needs in order to understand you. So what else always a contract needs is a constructor. So here we simply define our constructor with an initial supply of type balance and we return self. We could also return ERC20 here, but self is more convenient. It's basically the same. And for that purpose, we first of all, what do we want here? In our new constructor, we want to initialize balances so that our total supply that we give it via initial supply is owned by our caller. So caller has all the supply, initially at least. So first of all, we have to somehow receive the caller, and we get this by this line of code. Then we initialize our balances and need to insert the mapping from caller to the initial supply. This is done like that. And afterwards, we can simply construct it by having our total supply be initialized to initial supply and give it the balances, which is equal to that. But Rust has a short syntax which just removes it, and we are left with just balances. So now the only errors we receive are hashmap, and it says that it cannot be resolved to some type. And this is because we have not yet decided we have not yet told the Rust compiler what hashmap is, what kind of hashmap. We cannot really use the normal, or we can use the normal Rust hashmap, but it's not really useful in a smart contract because it's not it was not designed for being used in a smart contract. Instead, we use the specific Inc storage collections hashmap, and then we should have no more compiler errors. So let's compile this. Now we probably have to wait for a few seconds. In the meantime, we can glance over the code and see what we should or could do next. So this is still compiling. Next, we could, for example, add another Inc message. We because what we are currently missing is, for example, a way to retrieve the balance of some user. And we could do this in the following way. We define another int message named balance of. And in this, we simply say, hey, balances, give us, please give us the balance of this user that we gave to you. And if we do this, like this line of code, you'll see an error popping up. That's the naive way that you would think, because get returns an option instead of a balance. So we are returned with an option of balance and not with a balance directly. What we could do instead is we could say unwrap or. This is a message. This is a method coming from Rust option type that simply if the option is none, so if there was no balance that we retrieved, we default to 0. So if we have a non-existing account for this user, we simply default to 0. That's all it means. And now it still comes up with an error saying that this is a little bit Rust specific. So it said it returned us not only an option of balance, but also this U128 is basically balance. So balance is basically the same as U128. And we retrieved a type of option of ampersand U128. So we received an option to a reference of it. In order to fix this, we could, for example, insert copied here. And what does copied is, it turns a reference into a reference of T into a T. That's it. It's also coming from options. So this is how we would, for example, implement balance off for ink. First self balances, we turn the reference into a proper value, and then we define the default if in case it is missing. That's it. And we by this, we also included all the other failure paths that could happen. And by now, we see that the contract compiled. Funnily, it already took our balance off method. Let me recompile it again so that you might see that it's now working. And it's working now, and it's already the size of 17 or 18 kilobytes of WebAssembly. And if we take a look into it, this is probably a really bad idea. We could probably specify, turn it into...
Remember, we can't see really what you're typing right now. It's hidden by...
Oh, sorry. Can you see it? Can you see it now?
Yes, much better, thanks.
So I just turned the WebAssembly into the WAD format. And now I can actually inspect it as a VAT file. I hope so, at least. All right, this should actually live inside the target. So this is how our ERC20 module looks, or ERC20 contract looks compiled to WebAssembly text format. So this is a format specific for human readability. You see it's quite long already, but it's basically doing not so much right now because it just has these two methods and what we specified so far, basically. Have there been any questions so far, Thibaut?
There was no question until 2 seconds ago. Shrinking the window a bit from the bottom. Okay, so you mean, yeah, eventually move the window a bit up, but that's fine. I'll tell you. There was no question otherwise.
Okay. So then let's continue. What do we need else? So we have total supply getter, we have the balance of getter. We could need what actually is useful for an ERC20 contract, the transfer method. And this is specified as following. Sorry for all the typos. What does this ampersand mute self mean, by the way? So here we specified ampersand self. This is very similar to a view function from Solidity. So this means we won't, or this entire message won't manipulate contract storage, whereas this message that takes an ampersand mute self might mutate contract storage. And we want to mutate contract storage because we are sending balance from one account to another. So therefore we have to mutate it. Also, we are taking the account ID to which we want to transfer the balance and the amount of balance that we want to transfer. And finally, we return a Boolean parameter because that's what this Solidity C20 spec, from what I know, does. So let's start. Again, we need the caller. This time we call it via this. We are small self .env. So the syntax always gives us access to the environment. And as you could see in the constructor, it was like a big self with colon. Actually, you could also use the big self colon here from what I remember. It wouldn't change a lot, but it's more convenient to use the small one in whenever you can, because here we can actually access a self instance, which is compared to other languages oftentimes, for example, called the disk pointer. And here we have a self-reference. So first of all, we take the caller of this message call. And then what we need else? We need the, let's call this from for convenience, because we transfer from to. And what do we need else? We need the from balance, which we retrieve by the balance of that we just defined. And here we simply specify from and now return with the balance. Next, we have to insert a check if the from account actually has enough amount of balance in order to send and transfer this amount to the to address. And we do this by inserting this from balance. If it's smaller than the amount, we need to error out. And currently we do this by simply returning false. So as soon as our from balance is less than the amount that we want to send, we return false. False means error. We cannot do this. If we have enough, we continue, and we now need the balance of the account that we want to send to. And next, we simply mutate the balances of both. We do this by saying self balances, insert, and then we insert from with the new from balance minus the amount. And we say self balances insert to balance plus the amount. So, and it's important that we specify this in this order, and also for later if we want to, for example, emit an event in this occasion. And afterwards, we simply return true. True means, hey, everything went okay. We are fine. We're done now. So insert returns. By the way, these are in-place docs. Also, I think generated by Rust Analyzer. These are the actual docs by Ink. So this should be the docs from the Ink storage collection hash map. And as you can see, it returns an option. But we currently do not need to process this option furthermore. The option is simply the old value of insert if there was any. So for example, in from, we expect some value to be there. So what for example happens?
Robin?
Yeah.
We have a couple questions, if I can interrupt you.
Yeah,
One
sure.
about reentrancy attack. So Solidity has some known issues like reentrancy. Do we have any such thing to take care of while writing ERC20 contract in Ink?
Right now, we have a very similar model as to Solidity, but we were already thinking about extending the way we we are able to call and restrict ourselves in order to prevent attacks such as the real transy attack. So right now, I think we are in the same situation as Solidity for Ink, but we have the possibility to change this with new APIs in order to how we can interact with the contracts palette. And we were already thinking about that.
Thanks. There's another question. It's there's a comment that is doing. What is it doing? Maybe you can check it out. It's a cargo canvas node. It's a Git clone, basically. Where does this install to? It's asking. So I guess.
You mean cargo install? Where does cargo install? Or the thing is, I cannot read the chat. It's super tiny.
Oh, okay, sorry. So the chat, the comment is basically doing a cargo install canvas node from a Git, from the Parity canvas node GitHub with a tag and a false flag, and the person is asking basically where this is getting installed.
It normally gets installed into your .cargo folder, from what I know. I'm not sure about that though. Maybe you can confirm or disconfirm.
Yeah, maybe we can check with Andrew, and I'll check that. One last question. Is something like the Solidity Safe Math library needed for Ink for an ERC20 contract?
That's a good question. So when we are looking into the cargo TOML for Ink 2.1, we required the user to specify something like this. Can you see it actually? Is it,
yes.
Okay. So in Ink 2.1, we required the user to specify something like this in order to enable overflow checks throughout the entire compilation. In Ink 3, cargo contract takes over this role. So this is the default now. So by default, we always check for arithmetic overflows. And you have to actually add this to your cargo TOML file in order to disable this feature by default for your smart contract. So there are, however, some problems, but not related to Ink, more related to Rust compiler itself and maybe to cargo. So in the past, there were some occasions where it magically didn't work, and sometimes worked and sometimes not. So it's a little bit of a tragedy, but not much related to Ink, more related to Rust being sometimes a little bit too young. You have some problems.
All right, thanks.
So I think I'll just continue with the ERC20 contract. And this already looks pretty much like an ERC20 contract. So we have a way to instantiate our contract, to retrieve the total supply, to retrieve the balance of a user, and to transfer balance from one account to another account. And what else do we need? I think what might be nice for third-party users is if we add events. But first of all, let me quickly compile it again to see if it still builds, and etc., and like how big it is. And it's always nice to know. And while it is building, we specify another event. And I do this by specifying Ink event. And we simply state, oops, I forgot the struct, this is how we define a new event. I'm not sure if we've already implemented this, but maybe it should also work with enums. Not sure. Might work with enums in the future. First of all, we specify the source of the transfer. So let me quickly describe to you why we need events. Events are something that third-party tools can listen to so that they can extract information throughout the time of the execution of a contract. And not only that, it's also sometimes important for light clients, etc. And for example, let me quickly finish this. in general, we try to heavily lean on solidity. So what does it mean? We, for example, can specify indexed arguments by providing this inc topics field. I'll just add it to all these. It's just topic, sorry. And then we have our event definition. We could also just specify some documentation. And generally, if you specify some documentation for your smart contract, it will also end up in your metadata that I'll quickly show you. Let me show it for this constructor. Let me quickly add documentation to this as well. Here. So if now we are done with compiling the smart contract. It didn't grow too much, interestingly. Let's generate some metadata for it, so that we can actually inspect the metadata that is being generated for our ESD20 contract. This again will take a little bit of time, since we are now doing a little bit more than we did in last time. So I don't know if you can actually see it, but compiling for metadata actually changes the entire code gen of inc. So inc, whatever you specify as your smart contract, has several different outputs, and the WebAssembly format is one output. But there can be also an output for the metadata, where the inc contract is completely differently compiled, so that it actually generates the metadata instead of a contract. And also we can test our contracts. And I think this is what we'll do after we have inserted our events. But now, while this is still compiling, let's just quickly add an emitting of the transferred event to our constructor, for example. We do this again by self.env in order to access the environment. Then we can specify emit event and say transferred. And this is just this this is a normal Rust constructor syntax. So with this braces. And here we can simply specify the from and we specify it as none, because initially there is no source of where any balance could come from, but 2 should actually be the caller. And the amount is simply the amount that we specified as initial supply. So this is what we have for our constructor event imitation. And we could also insert this into our transfer. Obviously, I would change it to a small self, just for convenience. And here I would change it to 2, and here to 2, and here to from. And this is all we need. Obviously, initial supply is no longer in scope. So this is all we needed in order to emit our event. And now we can just have it, and that's it. So it's all very much integrated into the entire chain. One thing that I wanted to talk about, because it's apparently not well known among inc users, is that inc allows you to have multiple implementation blocks. So you cannot only have one. This is going to become more important later if we specify, for example, or if we are working with traits, etc. Also, sometimes implementation blocks are important, for example, because you want to compile them in different fashions, etc., or annotate them with docs. And yeah, you can do different stuff with different implementation blocks. So it's always convenient to have multiple implementation blocks for whatever you are implementing.
There's a question regarding how about the traits? I know you want to talk about this toward the end, but maybe you can address this now.
So traits are a very asked feature right now. I can also, I can also.
I mean, I didn't mean you to jump to this part of the presentation. We were like 30 minutes in, 35 minutes in. Just if you want to answer this question.
We'll definitely cover traits, and if many people think they are super important and this is the only thing they want to see, we can also do it earlier than what is planned. We could just do it now, basically.
Up to you. Up to you. You're the master.
Yeah, sure. Okay. So I think right now we are set up with everything. There are some tiny modifications I'd like to do beforehand, though, before we actually refactor it as traits. First of all, I really hate that we are handling our errors with this Boolean. It's just a personal opinion, but this is not good Rust style. So if we are programming in Ink, and we are programming in Rust, and therefore we should use proper Rust style and notation and shouldn't follow conventions forged in other languages such as Solidity. And for that purpose, I'll simply generate a new enum called error. And this is more or less what you would normally do in just very normal Rust applications. And would give it, for example, insufficient balance as a variant. And the next thing I always do for error handling is I make an alias to the normal Rust result type that is going to be used throughout the entire contract. So this is the ERC20 error types. And this is the ERC20 result type. So whenever an operation of our ERC20 contract can fail, we'll return this result type. And the metadata will be able to tell us exactly that. And as I can see now, our metadata has just finished compiling. And therefore, we can now access it. It's just lying in our targets directory. You can see it's very different from what we've had in Ink 2.1. So first of all, it specifies the current version of this metadata because we expect it to evolve over time. Then it has a source section, basically telling what language we use. Note that we can have multiple languages that compile down to the same metadata format. One of those alternatives is the Solang compiler, so the teach-to WebAssembly compiler. So in this case, something like Solidity would stand here with some Solidity version. Compiler would be Solang then instead of Rust-C. The hash is the Blake2 hash of our WebAssembly compiled binary. Next is the contract section, simply the name, the version we specified in our cargo DOML, and our authors. This could, for example, be your name. And in the spec section, we see Ink-specific information. For example, we see a section for all of our constructors, their arguments with their name, and especially also their type. And also the documentation is inserted here. So what you can also see is more low-level stuff, such as the selectors. Selectors is coming from the way Ink is being called. So in Ink, when Ink is compiling itself, it generates something like a single function that is able to dispatch into all of its messages or constructors. And the selector is the 4 bytes that basically tell from the outside which message we want to call.
Do you know if the hash will be the same as the blob uploaded to the chain? That's a question from the chat.
This one?
Yeah.
That's a really good question. I don't know. I really don't know.
Sorry, Marco, we don't know. We need to check.
You can try. You can try it out.
There's another question linked to the code. I don't know if you want to finish this on the metadata, or the question is, does self-env color, is it ensuring that the message is signed by the caller? And is it returning the account ID?
Self and caller, this, you mean this, right?
Yes.
Yes, it definitely returns an account ID. I could also specify it as that. So this is a Rust type annotation. And it's returning to us the sender of the message, yes.
And is it ensuring that the message is signed by the key from this account ID?
I don't know. I cannot tell. This is maybe something maybe Andrew knows. I don't know. Also, I cannot tell. At least Ink cannot tell if this is actually happening.
I guess it should, but
I hope.
Andrew, you're muted, but I don't know if you know that.
Okay, I think I cannot answer this at this point. Maybe Andrew can later if he unmutes.
Can you repeat the question? I think I might have
sorry.
been. Yeah.
We're asking if the color from ANF color, are you actually checking that the message is signed? Like when the color, like an account is calling this transfer, do you verify the signature from the message?
I believe it won't get to this point unless it's a valid signature. So it has to be verified first.
Right, and this is verified, I guess, in lower level of
Yeah, that happens in the you can, anyone can see. Just have a look at the contracts palette in Substrate, and inside the call function, which is anytime you send a message, then it goes via the call function in the contracts palette. That has a call at the top which says something like ensure signed, which does the check.
Thanks. Also, okay, Alexander just answered. Thanks a lot.
Nice.
Was I correct? He's the master, really.
Yes, that's correct.
Yeah, Alexander is the implementer of the current state of the contracts palette, so he can answer all these questions.
Thank you.
Have we been? Any other questions, or can I continue?
No, that's good so far.
Nice. So I think I've also basically I think we are done. The only other more or less important section is in the metadata. We scrolled through the constructors and the messages right now. Is the storage section. We currently do not really make use of this, but we'll definitely are willing to do so in the future. It is a section that describes the storage layout of the contract. So here we see, for example, the total supply, and it says on which key it's lying. It says which type for decoding and encoding it has. So the metadata of an Ink smart contract also contains this very valuable information to third-party tools. And the last section is just types, that are required by third-party tools so that they know how to decode and encode certain types, etc., and how they are composed. This is more complex than it should be, but it is like that. So now that we have our error and result type, we can finally apply this to our transfer method. And I'll simply show this. We'll return result of empty parentheses. This is empty parentheses are the void of Rust. So this is just the type that has nothing. It's an empty tuple basically. And now if I press save, there should be some error messages popping up saying that, hey, you're returning the wrong type, and actually we are. So let me quickly fix this. We just return insufficient balances if there are insufficient balances. And otherwise, we return OK. And I think that's all we have to do. And there's one other message. Okay. That's a good one. I actually forgot to implement the scale codec for the error type. So let me quickly fix that. So now our error type is actually encodable, and I just added this one line. And there's yet another error. Type info is also not included. So let me add this as well. And now we hopefully have it. So by adding derive of scale encode and scale info type info, we are now done with our error and can finally return it. And we should no longer have compiled errors. But we do. This is unfortunate. Yeah, I see why. So in this example, I just specified the derive of scale info unconditionally, but this is wrong. What we need instead is we need to check if we are actually under the right compilation target, and only then we need the type info. And we actually need to derive it, of course. So what did I change? I changed it to the CFG ATRA. It's kind of like a conditional compilation in Rust. So we only derive for scale info, type info, if the feature std is enabled. So we only do this if we do not compile our smart contract for being deployed as a WASM blob. But for example, we do this when we need our when we need to compile it as metadata, for example. So metadata needs the type info, but normal WebAssembly smart contracts don't need it. So this is therefore we need to insert this conditional compilation. And if we do this and compile again, we should see the effect of it being accepted. And one thing I wanted to note furthermore is that if we, like, you might still remember that it took a while, like 1 or 2 minutes to compile initially our smart contract. But if we compile it now, it's called incremental compilation, we actually finish in under a second. So only the first compilation is really expensive, and then you have a very fast development cycle where you quickly change some things, and within 2 or 3 seconds at most, you have your new contract, obviously depending on how big your contract ends up to be. So if you program something that is 10,000s of lines of code big, you probably won't end up in 2 seconds of compilation time. But most contracts should be fairly small and contained, so should be okay. What else could we do? One thing is, this is not very usual for Solidity events, especially not for the transfer event, and it's definitely not useful from what I would say. But what we could do is just to demonstrate a new feature. We could tell the incompiler that our event is anonymous. The reason is that our inc topic, or generally annotating some event arguments as being indexed, adds a significant amount of overhead to your runtime of the contract, since it needs to compute certain hashes, etc. in the worst case. And those hashes are not inexpensive. And especially it needs to do this also every time for the signature of the event, which is for our case ERC20::: transferred. So we, for example, take a Blake2 hash of this every time we actually call we emit a transfer event. Obviously, there are ways to improve this. Those are not yet implemented, unfortunately, but will come in the future. But the anonymous specifier just prevents at least this one topic from happening. So we reduce a little bit of our time. This is especially useful if you want to add custom events to your to already existing smart contracts to extract certain information, but without adding any of these topics. So and then if you declare it as anonymous furthermore without any topics, you completely avoid all these cryptographic computations, and you end up with emitting events far cheaper than without this. So events have overhead, and you can eliminate some of this overhead with anonymous events. And these are new to Inc. 3, borrowed from Solidity. Another new feature is that we can now specify messages as being payable. So previously in Ink 2.1, all messages have always been payable. Payable means you can send funds while calling this message. So you might remember if you call an extrinsic and therefore, for example, calling a message of an account as extrinsic, you can transfer some of your tokens to the account of the contract. This is very useful if you keep in mind that contracts accounts have to pay for their state due to state rent. So there is some new economics developing in contracts that you need to somehow keep them alive in order to further use them in the future. And you can do so by flagging messages as being payable. So otherwise, if this message is not payable and you send funds to it, it will just immediately stop execution and says that the extrinsic was failing. So you can just add payable to whatever message it makes sense. I'm just doing it here to all of the messages because for this ERC20 contract, we have not yet developed a concrete plan in how we are planning to keep this ERC20 contract alive in case of having state rent and storage rent. So we somehow have to like in this new ecosystem of substrate chains that have state rent and code rent built into their nature, we have to develop new ways in how we program our contracts. And Ink tries very hard to help you with that, to help you design your contracts and interfaces to your contracts in a way that they can stay alive, basically. And it's a whole new ecosystem and way of thinking required that is not at all similar to what we know from Solidity.
Quick question, Robin, regarding events. Are these events accessible to other smart contracts or only to the calling client?
So you mean if there is another smart contract depending on my ERC20 contract, for example, calling it directly?
I guess so, yeah.
That's a good question. Let me think. I think from the current standpoint of code generation of Ink, they are accessible if you export them. So you might see that we specified it as public. What we could do is outside of our Ink module, we could say pub use ERC20 and then transfer it and make it public to the outside. If we don't do this, we won't make it public. And we could also make our ERC20 contract public. I actually wonder right now how documentation, if we generate documentation for our smart contract using cargo doc -- open for just immediately opening it when it's done. I'm just wondering how, and I seriously wondering right now, how documentation is actually generated for this kind of re-exporting. I do not expect too much, to be honest, because documentation generation has not been built into Ink. So Ink does not yet do special compilation efforts in order to make documentation as beautiful as it can get. But this is also a feature that we really, really want in the future, so that if you do cargo doc to generate some documentation, you automatically get some beautiful documentation output for it. But yeah, this is basically it. So if you want to export your definitions, your Ink definitions to the outside, you have to re-export them using just normal Rust syntax. We are nearly done compiling our documentation. Are there any other questions that I could answer in the meanwhile?
Not really. There's a discussion going on, but no real question.
Okay. So while this is still compiling, I could show some other features of the Ink 3. We're nearly there, so I'll not let myself being interrupted. So there we are. And let me quickly move it to our screen. Oops, not what I wanted. This is actually not working. It's not working because we are Chrome in Firefox. Can you see the documentation?
Yes.
So this is what we just generated for our Ink smart contract, and it's not super, it's not super readable, but the documentation is there. Fields are omitted because we didn't specify them as public. And if we click on our ERC20, you might see that it's looking a little bit, it's not what we implemented. So you see a lot, but nothing that would come to your mind when you would think about your own ERC20 contract. So this is a result of Ink not respecting the doc compilation target, but it will definitely do this in the future. So expect that documentation generation is going to be a thing in newer Ink versions, in the future Ink versions. Right now, it's not. So let me demonstrate yet another cool feature of new Ink. Furthermore, I was already telling you about selectors of functions and constructors. And you can control these selectors directly via this via this selector attribute. So you can simply say selector equals and then some code hash that equals to 4 bytes. So always 2 digits is 1 byte as usual. And it has to be prefixed by a 0x to just make it visually pleasing that this is actually a hex representation. And if we, for example, generate the metadata now, again, sorry that you cannot see it, but I just specified cargo contract generate metadata again. And when we now wait for it to be finished, now it's finished, and then we inspect it and go to total supply message, I hope this is it, we will see that our selector now is CodeGephi. So exactly what we wanted. And this allows us to change the name of our method and not break any of our dependent contracts, because they are not using the name, they are using only the selector to call us. So this allows us to be able to refactor our contracts even with their names at a later point, even though it has some dependencies, and we won't break any of them.
A quick question regarding the production readiness of Ink. Miguel, which I forgot to ask the question before, sorry about that. He's asking, so is it production ready Ink? And if it's not, what aspects are missing to make it so?
Yeah, production ready. This is a good question, first of all. A little bit unspecified, though, what exactly means production ready, because production ready is different in different people's minds. What I can say is that Ink 3 is currently a release candidate. So what we released with it is a release candidate. It's not actually even released in that sense. So this means that the current Ink 3 RC1 may and probably might contain bugs that we are going to fix, and it might have a lack of certain features that we will add before we will actually release the proper Ink 3. So far we released Ink 3 RC1 so that you can play around with it, toy around with it, report all the things that are necessary to you, that you need to be added, that bugs that you found that shouldn't be there, etc. And I guess and hope that in a few weeks, not more than that, we'll release the proper Ink 3.0, and afterwards targeting other versions of it on top of it, obviously. From the standpoint of it being production ready, I can say only the following. It was a complete re-implementation of what we had so far in Ink, not a complete rewrite in terms of, hey, let's rewrite the whole stack, but we took a component, looked into it, thought about what is wrong with it, thought about what problems it has, and then we completely replaced it in many occasions with an entirely new component. This happened with the ink event crate, with the ink storage crate, with the whole ink cogen, and piece after piece we've replaced them, and now ink 3.0 is basically a completely rewrite after all these changes compared to ink 2.1. And this mirrors in significant improvements to the code generation and all the features that have been implemented now. But also it could mean that there are bugs that shouldn't be there because it's still a brand new tech. But on the other hand side, we've been very careful implementing it. We've added tons of tests. We have a very, very robust CI system that catches tons of stuff. We even ran the Miri tool on top of our test suite and actually catched some undefined behavior bugs with it. So that was an invaluable experience. So we really tried our best in keeping the quality as high as possible. But at this point, I think the production readiness is being stopped by just it being too new to actually make a statement about this.
Mm-hmm. Thanks. And another fresh question, what is the plan for the smart contract and runtime interaction? So I imagine that we're talking about.
I think I can remember we having answered this question multiple times already today, but it's a good question and it's an important question. So we have had this feature that smart contracts could dispatch into the runtime in Ink 2.1. We removed this feature from Substrate 2 because we have the vision of a much better implementation of it called chain extensions in the future. This is a more general term and allows runtime engineers to basically plug into the contracts palette some very generic custom functionality that contracts then are capable of calling. And the interaction, the bridge is done as with Ink 2.1 through the environmental trait. So I'm not going to demonstrate it today because it actually deserves its own workshop, but this is basically the bridge that allows Ink to work with any chain and not only the default specified and default configured chains for Substrate. And yeah, it should also be type safe in that regard.
One last question. Sorry, there were a lot recently. How about composability between parachains, smart contract parachains? This is...
What does composability mean in that regard?
Yeah. I imagine between different parachains that or smart contract parachains. I don't know. That's probably very much the future, like far future.
Yeah, I don't know what the person who is asking this means with composability. But
I can ask and
but the vision we have is that it should be possible in the future to allow runtime engineers of parachains to at least enable this feature.
Mm-hmm.
I think I'm not able at this point to specify more than that.
Right. No, but that makes sense. So the smart contract would talk with the runtime would transfer some messages cross-chain, cross-parachain, and if the parachain on the other side is able to do the same but reverse from runtime to smart contract palette, then why not?
Yeah, and ideally the user wouldn't even see any of this magic, but I'm not sure if this is feasible.
Yeah, I mean, that's good question. Can't answer. Just for a quick heads up, we are 1 hour and 5 minutes in the line.
Oh, damn. Okay, then I'll speed up. We also want Andrew to demonstrate his magic. By the way, Andrew, are you ready for this?
Yes.
Then I'll definitely speed up. And we'll first do this demonstration how to call this smart contract. And if we later have time, we'll also implement some traits on top of that. Will be super quick though. So without further ado, I think we are ready for the demonstration that Andrew can do. So what we are going to do is we want to deploy, instantiate, and execute our just written ERC20 contract through Cargo Contract CLI and the new Canvas UI. And now I'm closing.
Okay, can we see?
We can see, yeah, 2 terminals.
And yeah, is the text big enough to read?
It's not at all big enough, at least not.
Yeah, please. Yeah, that's better. Thanks.
Okay. Wouldn't it be amazing if we could instantiate and deploy the contract that Robin just wrote for us using Cargo Contract? We could if it worked, but I'm able to show it for the Flipper contract, which is close enough, and we'll show the same concepts. For some reason, it doesn't work on the ERC20 contract.
It's not on the examples one. Also not on the Ink repository example one.
I mean it doesn't work.
Oh. Okay.
Yeah, it's just to do with the encoding of the account IDs as a message. It's currently broken, so I don't think it's going to work.
Yeah, we've had a lot of problems like these in the past days.
Yeah. So yeah, a lot of this stuff is brand new, so it may or may not work. But let's give it a go. So can you see also the Flipper contract on the right hand side? It looks familiar. Is it big enough? Is it really small? Okay, cool.
Like increase fonts by 10.
By 10. Oh yeah, it's because I've got a really big screen.
Yeah, but since we are not, I think
we're not going to read too much the code anyway.
Yeah.
Yeah. But nonetheless, okay, right. So let's remember we just got Cargo Contract. So we built our contract as Robin demonstrated, and we need to generate the metadata. In this case, yeah, it's required so that we can encode and decode the arguments. So when sending a message to the contract, we need to know what the types are in order to serialize them. So I've generated the metadata. Now here comes the new command. So we've got deploy, which is putting the code to the oh, hang on a second, I've missed a step. Excuse me. I'm going to show using a local Canvas node, which you can download from here. And
is this repo available to anyone now?
It is public, yes. It's public,
Okay.
yeah. It's Parity Tech /Canvas dash.
I'm going to post it in the
Yeah.
Thanks.
So we do have a testnet running, probably everyone's aware of, but I'm going to demonstrate using the local node. It's sometimes a better idea because you have more control, and you have access to all the money on there. So the first thing you normally do is, if you're working with it, you don't need to do it the first time, is purge the chain, because then you have then it kind of clears the database and starts it from fresh. So you can see there purging chain. So it's a good practice just to do that every time, because then you've got a blank canvas, so to speak, to start with. So now we run it. So we just remove that. Now this bit says dev, which means we're running just a single node dev chain locally, and it runs. It has RPC ports open at default addresses, so we can run it. There we go. So now our local canvas chain is up and running, we can deploy the contract that we just compiled there. So here we have the new command deploy, and this bit at the end, SURI, that stands for secret URI, and that is the that is one of the built-in dev accounts, which in this case is called Alice. There are other ones, you know, Bob, Charlie, and so forth. If when you're interacting with the with real accounts, then you would put your kind of private key there, the role private key. But you know, we plan to implement proper kind of secret signing in the future where it's password protected. But for now, that's the way to do the signing. So we're going to do Alice. So all this is doing is uploading the code to the chain. Right. So now that's successfully uploaded to our chain, and here we have the code hash. So I'm going to copy that, and now we can instantiate it. Right. So here in the code hash argument, I'm going to paste the code hash. So that's the code blob that I've just uploaded. Robin, I don't know whether Robin explained already about the difference between that and Ethereum, where, you know, there are two steps to creating a contract. In this case, there's uploading the code, and then there's creating an instance of it, and that allows you to create multiple instances of the same code, so it avoids storage bloat on the chain if many people are using the same contracts. Right, so now I can call instantiate. So let's just draw attention to a couple of the arguments here. So this here is the name of the constructor we want to call, and that corresponds to this constructor here on the right-hand side. And then this is an argument to that constructor true. So you can see we're setting the initial value to true. This endowment is how much value we want to give to the contract, and that is used to pay for state rent, essentially. So the contract has an account, and that's how much value we want to transfer to it to start with. And again, here you can see the account we're using to sign the message. Right, okay, so here you can see the system events that were generated, and we can see here that it was a success, and now we have a contract account. So we're going to copy that. So now we have an instance of our Flipper contract running on our local chain, and now we're going to query it. We're actually going to query to see what the state. We're going to call this function here on the right hand side, which is get. So I'm just going to, so I'm going to call get, and you'll see here that I've added the RPC argument. So what this means is that instead of sending a transaction or an extrinsic, it is just calling an RPC. It's calling it without any, it's not actually executed as a transaction on chain. So it's just querying our local node for the state. And I think people will be familiar with that concept from Ethereum 2. So it doesn't cost anything, and it doesn't also change the state of the chain. So we initiated it with true, so I'm expecting to see that the value is true. Excuse the formatting. That's the bit we care about. Right, so now we're going to actually execute a transaction. Looks like I need to update that. So now I'm going to call, now you can see I've changed to flip, which corresponds to that message on the right hand side. There we go, let's call flip. Okay, well, there's no events if there were events raised by that, then we would like to be able to see them there to kind of see that we've had some effect. So I'm going to call get again, and we can see that it's changed to false in this case. So those are the three main new commands that will come as part of the next release of Cargo Contract. As you can see, there are a few wrinkles that need to be ironed out before I can release it. There's various things I want to do regarding making it more user friendly. You don't have to cut and paste these code hashes and accounts into the command line every time. It will maybe have some kind of session going on, and obviously improve the signing experience so that you don't have to paste your private key onto the command line, which is extremely undesirable. But for development purposes, it's perfectly fine. So let's try one more thing before I show the Canvas UI. I haven't. So let's see whether the events work. Right. So I've just added an event here, flipped, and there you can see it being emitted in the flip method. So now we need to rebuild the contract. The metadata will have changed because it's got an event. One trick to know about is if you call generate metadata, it calls build as well. So probably they should be combined, unless you only wanted to build it without doing the metadata. Any questions so far?
Nope.
So that's obviously compiling. The joys of Rust. Okay. In the meantime, then I'll use the time to move on to the next section, which is. So that was using the command line client. So here is the Canvas UI, which is probably, I suppose most people will use the command line client for kind of development purposes because you can, it's quicker and some programmers prefer that interface. But I guess when you're interacting with real value, probably the user interface is the way to go.
Just a couple questions just popped up. So one, are there equivalents of Ganache and MetaMask for Substrate and Ink contracts? Yeah.
I believe there is a team that's been funded by Web3 Foundation that are working on something like that.
Yes.
I don't know what stage it's at, but I believe that is.
I'm going to look around on the internet and post a link of that. There's a grant definitely that was posted for that. Yeah.
Yeah. And yeah. Also, I believe that you can, if you want to actually use. So Ganache is the one where it kind of has a fake, not a fake, like a mock blockchain instead of. Yeah. So, I mean, there is an alternative to that, which I've not actually tried, but you can set Substrate up to do manual seal so that it will, if you kind of do a transaction, then it would immediately, it won't wait for a block, it will immediately include it in the block. And so you could use that mode and use an actual chain to have the same effect.
Yeah.
Right, okay, so now we've got a new one, so we have to deploy it again. Okay, we've got a new code hash. So we have to instantiate it again. one thing to note is that I believe that for a given code hash, you can only deploy once an instance of a contract per account, because I think the hash is based on the hash of the code and the hash the combined hash of the code and of the account that's deploying it. So that's just something to watch out for. Okay, so I'm just going to instantiate that contract. And now I'm going to call flip. If it works, it will be ugly. Okay, so ignore the debug output, but you can see that essentially it has given us back the flipped event and with the value there. And obviously I need to do some work to make that pretty, but there we go. You can see the event being raised. Right, okay. I'll just move over to the UI and do something similar. I think we'll stick with the well, okay, we'll go to the Canvas testnet now. So instead of my local one, we use the Canvas testnet. So here in the bottom left, you can select. I was connected to my local node. Now I'm connecting to the public Canvas testnet. And I'll just show the flow of this. Hang on. How are we doing for time? Do you want me to show the creation of accounts via the extension, or shall I skip that? Skip that part. Thibaut, do you want to tell me how long I've got?
It's 1 hour and 22 minutes, so roughly 8 minutes if we want to be on time, and we can be a bit longer, but not too much, I guess.
Okay. Right. So I suppose this is useful because I learned how to do this the first time today. So here I've installed the Polkadot extension, which you will ultimately use for signing your messages that you send to the contracts. So you can use this to create a new account. And then, well, actually, I'm almost certain you won't be able to see this because I'm straining to see the Can I increase the size of that? No. All right, I'll skip over that.
What you can do is open it in a separate window and make it bigger. If you click on cancel, and in the option in the settings here and the cogwheel, and open in and I guess this is gonna allow you to make it bigger. Exactly.
Yeah. Okay. Right. There we go. So so we're going to create a new account. I'm not going to derive it. Just ignore that. And there's a button down there. Right. So normally, obviously, take care to save that somewhere extremely safe.
You need a 6-digit. Yeah, I'm building the extension.
There you
So
go.
if you have a bug, then that's my problem now.
Right. Okay. So so now we've got our new account. So here is the public address, and we can copy that, and then we can go into the faucet. I don't know whether I can. How do you zoom in on this? Anyway.
Yeah, control scroll probably.
That doesn't work. Okay, I'm typing. I'm putting in my address into the faucet, and then it should give me some money. There we go. And what you can do as well is you can go to polka.js and go onto the Canvas testnet. It should be on in the list of test networks. And you can actually have a look at your. So that's another one. So I'm just going to add this. Can you see, is the text big enough on the screen?
Yeah, kind of. I just posted the link in the chat.
Yeah. And so you can go to, you can add your. You can I just copied that address that I created here into the polka.js interface. Right, there you go. And now you can see that I've got half a can, which I assume means short for canvas. Right, so we've got half a token there. So that now allows us to kind of perform operations, we hope. So, well, I'm going to try Robin's now and see whether it works. I'm not sure whether it does. So I'll just refresh this page. So it picks up my account. There we go. So you can see that the demo account is in there now. Right. So here's our compiled ERC20, and this is the result of compiling Robin's contract earlier. Oh, dragged it into the wrong box. Okay, there it is, and there's the metadata. And here it shows us the various methods we can call. Okay, so upload. This is the equivalent of the deploy command on the cargo contract. Probably will unify the names. Upload is probably better. Oh, so sign and submit. Okay, so here it's talking to the extension. Thibaut, what did you do, man, with this poor
No,
design?
scroll down. Oh, damn, you can enter. Usually, it should be actually.
Oh, hang on, I've done the wrong. Right, let's try again. Demo. Okay. So let's try. Okay.
This is horrible.
Why is it going from stash? I don't want to. It's trying to do it from the wrong account. Okay, I'll just try one more time.
Probably from the drop down, I guess.
Yeah, I'll just refresh the whole thing and start again. Okay, so now it's on demo. Definitely on demo. Try again. Okay, so it's account demo. That's the one that I created. Demo extension. Stash.
It's still sending the stash. Maybe try to change in the drop down on the Canvas UI just to make sure change to another and then go back to demo. Maybe this is picking it up.
Yeah. Okay, under extension. Under extension. Huh.
Still the stash.
Is that a drop down in the?
Yeah, that's the signing, the extrinsic that is sent. That is basically different. Oh wait, sorry. No. Look, there are different transactions. Yeah. Sorry.
Oh, I see. There's 4 of 4. Okay.
Yeah, they were just waiting, basically. Yeah.
There's a queue of them. Okay. Well, let's see. Can I do the one of the original ones? There we go. So number 2, I can do. That's a demo one. Stores. Okay.
Maybe cancel that all. Like scroll down and cancel them all. Like
I see. Oh, okay. Yeah. Okay. Well, I'm glad the actual inventor of this plugin is on the call. There we go, cancelled.
I'm
Okay.
not the inventor. I'm just a developer working on it.
Right, okay, let's try again. So demo, it's kept that stuff, so hopefully this should work this time.
Yeah, it will.
Oh yeah, sign and submit. I always forget that extra step.
Maybe you can try to control and scroll so that to make it smaller again. But yeah, whatever, it should work. Yeah.
Okay, cool. So those are the events. So store the code, right? So we're just going to deploy it, which is the equivalent of the instantiate command that we saw. Let's see. So initial supply. Yeah, just 1 million. The endowment, what's this now? This is can. I've only got 0.5 can, so I'll just say, okay, well, let's give it as much as let's just give it 0.4 at least. Okay, so let's see. Success. Right, so now it's deployed and we can execute it, which is the equivalent of the cargo contract call that we previously saw. So let's first do one of the query methods to see whether it works. So we've got total supply, which is just kind of shows us that it doesn't actually work. This is what I was getting earlier. But you would expect to be able. That's the equivalent of the RPC query that I was doing from the command line. So it calls it without sending a transaction, and you can also send it a transaction. So let's do a transfer, and I'm going to transfer to someone else. Just an amount. This might. What I was getting earlier was this was working, but well, we'll see. We'll see what happens. Send this transaction.
Probably need to sign, don't you?
Yeah. I was evicted. Right. Okay. Yeah. So we did try and it's to do with the state rent. So it seems that it's collecting the state rent, and that I didn't endow it with enough value. When I instantiated the contract, I should have given it more value, so it could have stayed alive for longer. But I don't think I'm going to go back and do that. But so you get the idea of you get the feel of the user interface. You'll be able to see the history of the calls you do on this below here, and the way that you can submit a transaction. That's it. Thank you, Andrew. Very nice demonstration. One thing can you go back to the UI, please? One thing I wanted to talk is we currently provide you with too few cans upon our faucet. So we will increase this number because we found that the storage rent is way more aggressive than we initially thought it was. Obviously, these numbers are not final yet. They have not been adjusted to be final. And we need to fine-tune those until everything is as expected. So right now, a contract needs way more, costs way more due to storage rent than it should be. And this is basically why the contract has been evicted, even though we gave it 0.4 cans upon for endowment during instantiation. This is going to be fixed, so don't worry.
There's a related question, actually. Can we see how much gas is consumed for a transaction?
I think this is a very, very often requested feature, and we definitely will integrate this into this particular UI. So before you run, you'll definitely see how much gas the operation is going to cost you.
Yeah, that information is returned from the RPC call, actually.
But it's already implemented.
Yeah, well, I mean, I only know because when I was developing it, it displayed it in the debug mode. It displayed estimated gas to be whatever. So I've seen it. I'm hiding it at the moment, but there is something like that around. And Alex probably can speak more to that.
That's cool. Okay, I see we are already running out of time, kind of. There is so much more I would love to talk about. Maybe I can share the slides after this workshop so you guys can actually inspect those after the workshop. And maybe it's just enough material for 2 other workshops entirely. So maybe this is not going to be the last workshop that you can expect to see.
Are we cutting it today, or is there any more last question?
For the very brave people, we can also show the trade implementation. But we are already over time. I don't know what is the concept of this workshop. Can we actually make it over?
We have up to 2 hours, definitely. This is well, originally it's 1.5. I know that Chromecast is going to cut after 2 hours. But this is the end. There is probably, I'm not sure if there is some words from anyone, closing words. But I mean, if you feel like, go ahead. There's still like 25 minutes.
Yes.
Otherwise,
we can just are willing to see trade support for the ERC20 contract, then they can stay. I think that's
exactly. And everyone can watch it then later on replay if they have to leave. That's fine.
I'm going to leave in the meantime. Thank you.
Yeah, no problem. See you.
Thank you, Andrew.
Some people are asking, show the trade initiation.
Yeah, we should. Okay, then let me share the screen again. Hopefully works better this time. So, and here we are back again on my screen. Yes. Can you see my editor?
Yes, and it's kind of big enough, I would say.
What we want to do is we want to add trade support for our ERC20 contract that we developed so far. We have been very great at work without any unit tests so far, so we just skipped that section. That is actually really important, but let's just not go into detail of that, and instead build our trade support into our contract. For that purpose, we go outside of our contract actually, and go to inc trade definition. This is yet another attribute macro. And like it's very similar to our inc contract. It's just called trade definition instead of contract. And define our trade. I'll call it base ERC20. And in this base ERC20 trade, we will simply have all of these messages and our constructor as signatures and write into our trade. So a trade never needs implementation and actually declines implementation blocks. So as you can see here, the inc trade definition macro already tells us that it's missing some inc messages in inc constructor. We again have to add these to our trade definition, just as we did with the normal inc implementations. So I'll just briefly add them here. And now we see that balance and account ID is no longer available in this frame. I just prepared something while Andrew was presenting, so it won't take too long of your time. This brings balance and account ID back into our scope. Maybe we'll have some better solutions for that in the future, but until then, this is the way to go. We could also just import default environments, so making things a little bit less ugly from that perspective. And also environment, bringing environment into scope, making it again less ugly. But yeah, it's not ideal in my opinion, but that's about it. That's about how good we can actually go for now. Then also we need error and result into the outer scope. So I'll simply move them out of the ink scope into the root scope of our contract, of our library, Rust library. So they are available here. And if we import them via use super error and result, they are also going to be available inside our contract. So we still have them when we are needing them in the transfer. So now we have set up our ink trait definition. This is all that is needed. So trait implemented by all ERC20 respecting smart contracts. Yay. So this is everything that is needed. And now we can import this trait into our scope of the ink smart contract called base ERC20 and simply implement it for our contract. And now things are showing up red. We no longer need the public specifier because traits are, or trait messages are public by default. And what else is missing? Something else is missing. Things are missing here. Yeah, okay. Also, we are missing the ink constructor because constructor is also part of this trait. Never tested it for ERC20, to be honest. So here we are. We now have implemented this trait by basically copying over the parts that we already had. And by all means, I no longer see error messages popping up. So I think we kind of got it. And let's just look into, let's just compile it, see if it worked. Will take some time. During that time of compilation, we will copy over some of the tests I prepared in the for this workshop because I initially wanted to show you how to write your own tests. I'll skip that section now. And instead, we'll simply provide them to you without further ado. These tests are making use of Ink's off-chain capabilities. So you can test Ink contracts very easily using the off-chain test environment. And here you could see, for example, an Ink test definition. It's kind of a unit test where we first instantiate a contract with some given initial supply, and then we assert that the total supply is the initial supply and the balance of the Alice, because Alice is initially the caller, is actually the initial supply, etc. And now we successfully compiled our smart contract. We also want to generate metadata for it. And also, what we also want is, now that we have some tests, sorry if I may go a little bit fast right now, but I really want to show you these things. I include those tests.
Cool.
So that I included those tests so that I can show you that we actually really implemented these traits and are not only cheating to you. So it's the ERC20 contract really is implementing this trait now. It's not only a cheat hidden by Ink to you. And we can show this to you by, or I can show this to you by implementing, fetching the space ERC20 trait into our scope. Note that all of this here is Rust code. It's not really Ink code. It's just normal Rust code that you can write anywhere else too. The fact that it lies within our Ink module just doesn't matter here for our purposes right now. And for the demonstration purposes, to show you that this is really just a trait implementation, I'll show you that we can actually call this ERC20 as if it was the trait. And we can now say total supply, and we assert that it's equal to initial supply. And this should actually compile. obviously taking this first parameter, and it compiles. So this is the trade syntax that is deployed by Rust. So it's not ink specific, it's Rust specific syntax. And this says we take our ERC20 type as if it was the base ERC20 trade and call the base ERC20 total supply message using our just instantiated ERC20 contract. And this thing should be equal to our initial supply. And if we now execute all of this using cargo test, we can, what we'll just do, we will basically assert that we actually implemented this trade with our ERC20 contract. And hopefully the tests pass. After all, I just implemented it right away. Tests are passing, and tests are actually even making explicitly use of our implemented trade. And I think that's about it for our demonstration purposes. For trades, let me say one thing. There is another even cooler attribute especially useful for trade implementation blocks, called namespace, from what I can remember. It allows us to alter the selectors that are going to be generated for our implemented trade definitions. So you might see we here still specify the selector for total supply to be CodeCafe. This overrides everything. But if, for example, we have two trade definitions sharing the absolute same signatures, how can we, if we, for example, call a trade using this syntax, how can we differentiate them? And especially when we have dependencies within contracts, so a contract calling another contract, they are generating the same selectors if they share the absolute same signatures. So you can apply this namespace attribute to one of these implementations to actually disambiguate those selectors that are going to be generated. If not, you are going for the selectors. And yet another thing I wanted to show you, sorry for this speed right now, but we are not well on time right now. You can also specify all of those ink attributes always out of place. So I always specified them in place because it's, I think, more readable. But these forms are actually equivalent. So you can also do this, or you can that. You cannot do both at the same time. If you do both at the same time, ink explodes into your face, saying, hopefully something better than at this invocation. Let me just show. Oh no, it's a Rust bug. I'm sorry for that. It cannot be fixed for ink. I think if we remove this, if we remove this document, should be better. No, it isn't. I don't know right now why the error message isn't better, but Rust has some problems with procedural macros that include certain attributes in certain forms. And it's definitely a Rust compiler bug. It's not an ink bug, but ink suffers from it by sometimes not being able to do a better job at telling you what is wrong. So let's go back to the inline attribute format. And with this, I think I showed you everything that you need to know about trade definitions and trade implementations. I'm done. So I think we still have like 12 minutes left, and
there's one question from someone else in the chat. What can we do with trades? What can't we? What can't? What we can't? I guess.
Yeah, that's a really good question. So right now, this is the first and foremost really brand new implementation of trades. So never been implemented before. I also don't know any other Rust-based smart contract programming language that actually supports this feature. And I know why, because we've implemented it, and it is a hell of a feature to implement, really. Like, there are so many food guns, you cannot predict all of them. And it was a mess sometimes to get rid of those, because nobody would want to use a feature that employs 20 different food guns while using it. So you have to be super careful while implementing this to not shoot in your food and not make your users shoot into their food. So therefore, we limited, the current trait implementation support is extremely limited. And we plan to remove some of those limitations from time to time over the course of the next ink versions. For example, right now you cannot specify associated types, associated constants, or for example, unsafe constructors or whatever. Like you cannot do a whole lot right now with the trait support. And one other particular very important thing is, for example, making contracts generic. But this is a whole other cask of food guns available to you. So what we try with Ink is to provide you with a very safe, efficient, and highly abstracting programming language based on Rust that does not have all these food guns that are probably available for example, if you use Solidity. Instead, we try to go a path where we only allow for features that we know and that we are very sure that will not end in your food with a gun. So therefore, our current trait support is very limited, but expect its limits to disappear over time, hopefully. And also with Rust evolving over time, so will Ink and its features. Any other questions?
Not anymore.
Cool. So that motivates me to go back to my slides. Maybe we can actually get a big deal of the presentation done. Can you see my slides?
Yes, now we can see Firefox.
This is bad. Can you wait? I think I did a mistake. I think this should be it. Can you see my slides now?
Yes.
Cool. So obviously we were something like here. And in summary, we wrote a simple ERC20 contract. What we have not shown to you is lazy. Lazy, I think I'll skip over it because it's not too much of an importance here. Because we'll exploit right away. We saw emitting events, payable messages. I lied to you with simple testing because we didn't even dig deep into it. And we even saw the traits already because you wanted them. We've seen all of these things by Andrew. He demonstrated deployment, instantiation, and execution. And what I want to talk to you about now in this last 10 minutes is the storage organization. This is a section that has never been talked about in before, and we do not even have workshops or tutorials besides this particular workshop for it. And I originally decided to be in the middle of this workshop, but things expect chaos, etc. So we are going over it in the last minutes of this workshop. So first of all, if we are looking at a smart contract, and you might remember this slide from my presentation some hours ago. An Ink contract has a cache and has access to the storage through the contracts palette. While execution, it first pulls from the storage database, but only what it needs. Then it computes, trying to stay in the cache. The cache is efficient, the storage database is not. And it really only loads from the storage if it really cannot avoid doing so. And everything that, and all the definitions and data structures in the Ink storage crate are completely designed for exactly avoiding storage access, because those are extremely inefficient and extremely expensive compared to your normal cache accesses. In the end, you push the storage, so you have 3 phases for every contract execution for Ink, basically. And looking into your contract database, storage database, you see that we have 256 bit keys indexing into values that are of any byte sequence. And this, I think I'll skip over these slides because you might already know them from my presentation before. the point here that I make is we can either pack into a single cell or we can spread into multiple cells when we are storing a particular information into the storage database. And we can also combine those things. And the two most important traits that there are two most important traits that I want you to know when you work with ink, because those are key components to understand how ink storage and ink organization of storage works. And this should be definitely documented elsewhere because it's key to understand anything. There's this spread layout trait that for every type controls how it is spreaded through many cells. And every type that is supported to be put into the storage actually implements this trait. And examples for these are the ink storage vector, hash map, lazy, etc. You can also derive it from the procedure macro and create your own custom types for it. The mirrored type is the packed layout. So we have spread layout and packed layout. Every type that can be packed into a single cell implements this trait. And every type that can be packed into a single cell can also be spreaded, obviously to one cell, but still spread it. So we have this hierarchy. So every packed layout type is also a spread layout type. And that's basically all you need to know about these two traits. Examples of a packed layout type is, for example, a Rust I32, a bool, the normal Rust vector, not the ink storage crate vector, or the ink storage box type. Anything that is encodable by scale codec, and also your own custom types can also be packed. In summary, we have those two sides. We have the standard library that acts eagerly on the storage. Everything is packed, and boxes are for dynamic heap allocations. And we have the ink storage crate on the other hand side, where everything tries to be spreading the layout of the storage. It always acts lazily, and it boxes dynamically on the storage allocations. And
just a quick info, we have 3 minutes left and we're going to be sharp cut, so we should
thank you.
know about it.
But when I'm talking about lazy, what does lazy actually mean? So it only nodes basically 3 components. It's only noding from storage when it needs to. It caches everything that it has and will have need for it. And it stores only when the thing it loaded and cached has been mutated. That's basically the 3 components of being lazy. And all the ink storage crate components do exactly this. There are many more slides, and I will send you the slides so that you can teach yourself about everything of this. Slides are more or less self-contained, but I won't go into them in detail because we are just having 2 minutes left until we are getting this cut, as Thibaut just said. So I want to thank everybody who was listening to me for these more or less 2 full hours, and to Andrew. And you'll get the slides to teach yourself more about storage organization. And we will look into the future that we'll provide you with documentation about this, because it's really very important that you know how storage layout and organization works for ink smart contracts. And with this, do we have any significant questions? Because otherwise we can answer all the questions in Discord or Element.
Yeah, exactly.
I would be happy to answer those there.
Yeah.
Okay, thank you.
Thank you so much, Robin.
No problem. It was a pleasure.
Bye-bye.
Bye.